Hi, and today we will be presenting about round 3 year 7 mathematics project discovering the role of 2D and 3D shapes.
I'm Jia Hui. Today we're going to talk about points, lines, and angles, parallel lines, perpendicular lines, and related angles, congruent figures, line symmetry, rotational symmetry, polygons and circles, 3D shapes, plans, and elevations. First, we're going to talk about points, lines, and angles. As we all know, points is an exact location in space with no length or width. It has 0 dimensions since it is a place, not a thing. It is marked with a dot, which may have a small size of few mm, but the point itself has no width. For example, as seen in the image, the points are identified by their coordinates on the coordinate plane, which is x-axis and y-axis. The points can move left or right along the x-axis and up or down on the y-axis. For another example, points can use to identify locations on a shape or line. As the picture shown below, in this shape, the points mark where the lines intersect, which is point E. Lines is a straight set of points that continue opposite directions forever. It has length but no width, so it is a one-dimensional. There are 2 examples for lines, which is parallel lines and perpendicular lines, which is going to be presented by Zi Yu next. Angles is when 2 lines meet together. The meeting point called the vertex of the angle, which is point B. Line A to B and line C to B is called the arms of the angle. There are several types of angles. First is the straight angle, which has an exact angle of 180 degrees. Reflex angle, which has an angle it's greater than 180 degrees. Revolution, which is an exact angle of 360 degrees. Acute angle, which is an angle that is lesser than 90 degrees. Obtuse angle, which is an angle that is greater than 90 degrees but lesser than 180 degrees. Right angle is an exact angle of 90 degrees. Now we're going to talk about triangles. Opposite exterior triangles. Angle A plus angle B equals to angle E in this case. Angle A and angle B are the 2 opposite interior angles, and angle E is the exterior angle. There is some classification of triangles, by side and by angle. By side, we have equilateral triangle, which has 3 equal sides, isosceles triangle, which has 2 equal sides, scaling triangle, which has no equal sides. By angle, we have acute triangle, which 3 angles are smaller than 90 degrees, right angle, which 1 angle has 90 degrees, obtuse angle, which 1 angle has greater than 90 degrees. Now I'm going to pass this to Zi Yu.
And now I'll be presenting 10.2 Parallel Lines, Perpendicular Lines, and Related Angles. Parallel lines can be defined as 2 lines in the same plane that are at equal distance from each other and never meet. Perpendicular lines is defined as a straight line that makes the right angles, which is 90 degrees, with the other line. In other words, if 2 lines intersect each other at the right angle, then the lines are perpendicular to each other. Related angles are the pair of angles that are related to each other. For each pair of related angles, there is a particular name given to them. These angles are related to each other based on some specific conditions. Examples of related angles. Complementary angle. When the sum of the measures of 2 angles is 90 degrees, such angles are called complementary angle. Supplementary angle. When the sum of the measures of 2 angles is 180 degrees, Such angles are called supplementary angles. Adjacent angle. Two angles in a plane are said to be adjacent if they have a common arm, a common vertex, and a non-common line on the opposite side of the common arm. In the given figure, angle AOC and angle BOC are adjacent angles, as OC is the common arm, O is the common vertex, and OA, OB are on the opposite side of OC. Vertically opposite angle. When two lines intersect, then the angles having their arms in the opposite direction are called vertically opposite angles. The pair of vertically opposite angles is equal. Angles round a point. Angles round a point describes the sum of angles that can be arranged together so that they form a full turn. Corresponding angle. Corresponding angles are the angles which are formed in matching corners or corresponding corners with the transversal when two parallel lines are intersected by any other line. They have an F shape. Alternate angle. Alternate angles are shaped by the two parallel lines crossed by a transversal. They have a Z shape. Co-interior angle. Co-interior angles or consecutive interior angles are the two angles that are on the same side of the transversal. They have a C shape.
So, congruent figure is a figure or object that are congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the another. Example, if two figures can be placed precisely over each other, they are said to be congruent figures. This is the example. Symbol of congruent. The symbol of congruence is made from two symbols, one above another. There is a symbol of slide, which represents similarity in shape, and the equals represents equality in size. This is the example. Congruent line segments. Since both X and Y and P and Q are line segments, they are of the same shape. The length of line segment XY is equal to 5 cm and PQ is also equal to 5 cm. Hence, the length of both line segments are equal to each other. Congruent angles. In the above diagram, angle ABC equals 40, whereas angle PQR equals 40. If we overlap angle ABC on angle PQR, we will find that both of the angles are congruent to each other. As per the rule, two angles are congruent if the measures of both angles are equal to each other. Congruent circles. The shape of both circles are the same and the size and is also the same as the length of radius OR and OP is equals to 2 cm each. It also means that both of the circles can be easily placed over each other. To conclude, circle A is congruent to circle B. Congruent triangles. Side AC equals to EG, AB equals to EF, and BC equals to FG. Then angle A equals to angle E, angle B equals to angle F, angle C equals to angle G. Therefore, ABC is congruent to EFG. Whenever two or more triangles are congruent, their corresponding sides and angles are also congruent by the rule of corresponding part of congruent triangles. CPCT. Congruent figures versus similar figures. Congruent figures. In two congruent figures, both of the corresponding angle and the length of corresponding sides are equal to each other. Similar figures. In two similar figures, the shapes looks the same. This is because the corresponding angles are equal. However, the length of corresponding angles are not equal to each other. Next, we have Tian Rou to explain about line symmetry.
Hi, I'm Tian Rou and I'll be sharing the line of symmetry. The line of symmetry is a line which divides a shape or an object into two or more equal and symmetrical parts. A shape symmetry is when a shape is divided into two or more equal and symmetrical parts by the line of symmetry. An object symmetry is when an object is divided into two or more equal and symmetrical parts by the line of symmetry. There are three types of line symmetry: horizontal line of symmetry, vertical line of symmetry, and diagonal line of symmetry. The horizontal line of symmetry is when an object or shape is divided into equal and symmetric parts horizontally. A vertical line of symmetry is when a shape or an object is divided vertically into equal and symmetrical parts. A diagonal line of symmetry is when a shape or an object is divided into equal and symmetric parts diagonally.
I'm Wong Sze Leng from Year 7 Courage. I'm going to present you about rotational symmetry. Rotational symmetry is like having a special pattern that stays the same no matter how many times you spin it. Example, for a square, no matter how many times you spin it still stays the same. That is called rotational symmetry. The times you spin the shape is called order of rotational symmetry. So in order to find rotational symmetry, the order of rotational symmetry, there is several ways. And for your understanding, this is the basic way. We can draw a reference point up there, and every time we spin the square, it will still look the same. You can spin it and we repeat it like this is 1 order, 2 order, 3 order, 4 order. So square have 4 order of rotational symmetry. There is a formula to find rotational symmetry also, which is n equals to 360 degrees divided by x. N is the order of rotational symmetry that we need to find. 360 degree is the whole like full rotation, and x is the smallest angle of rotation. So what do we mean by smallest angle of rotation, which is every time we spin the square, it will like every time we spin the square, what is the angle? For example, we spin the square, and from this to this, the smallest rotation is 90 degrees. So 360 degrees divided by 90 degrees equals to 4. So square have 4 order. Okay. A pentagon, it looks the same after rotating it by 72 degrees. So that is the smallest angle of rotation. So we would replace 72. We replace x. We replace 72. X becomes a 72. Yeah. Then 360 divided by 72 is 5. So pentagon has 5 order. That's all from me.
Upcoming next, I'll be talking about polygons and circles. A polygon is a plane shape with 3 or more straight sides. There are triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Triangle have 3 sides. Quadrilateral have 4 sides. Pentagon have 5 sides. Hexagon have 6 sides. Heptagon have 7 sides. Octagon have 8 sides. Nonagon have 9 sides. And decagon have 10 sides. These are the regular polygons. All sides and its angles are equal. Sum of interior angle of a polygon. Sum of interior angle for a triangle is 180 degrees. The formula for sum of interior angle for a polygon is n minus 2 times 180 degree. N is number of sides of a polygon. Quadro is 360 degree. Pentagon is 540 degree. Hexagon is 720 degree. Heptagon is 900 degree. Octagon is 1080 degree. Nonagon is 1260 degree. Decagon is 1440 degree. Size of an interior angle in a polygon. The formula for size of an interior angle in a polygon is sum of interior angle divide n. Triangle is 60 degree. Quadro is 90 degree. Pentagon is 108 degree. Hexagon is 120 degree. Heptagon is 128.57 degree. Octagon is 135 degree. Nonagon is 140 degree. Decagon is 144 degree. Number of sides of a polygon. The formula for number of sides of a polygon is angle sum equals n minus 2 times 30 degree. For example, a polygon has an angle sum of 3240 degree. How many sides does it have? 3240 degree equals n minus 2 times 180 degree. 3240 degree over 180 degree equals n minus 2. 18 equals n minus 2. 18 plus 2 equals n. 20 equals n. The polygons have 20 sides. Sum of exterior angle and the sides of an exterior angle of a polygon. Sum of exterior angle of a polygon is always 360 degree. Formula for size of an exterior angle of a polygon is 360 degree divide n. Triangle is 120 degree. Quadro is 90 degree. Pentagon is 72 degree. Hexagon is 60 degree. Heptagon is 51.43 degree. Octagon is 45 degree. Nonagon is 40 degree. Decagon is 36 degree. Circle. A circle is defined as a set of points which are all the same distance from a given fixed point. Every point on the outside curved line around a circle is the same distance from the center of the circle. The properties of a circle. Diameter. A straight line passing through the center and ends on the circle's circumference. Circumference. A perimeter of circle. Radius. A straight line from the center to the circumference of a circle. Half of a diameter. Center. Center of the circle. Semicircle. A half circle. 180 degree. Angle at the circumference. Half the angle at the center standing on the semi-arc. Major and minor sector. Form when a circle is divided using two radii. Plural for radius. Major and minor arc. A curve of circle. Major and minor segment. A region of circle which is created by breaking apart from the rest of the circle through a chord. Does not pass through the center of the circle. Chord. A straight line joining the ends of an arc. Major, bigger. Minor, smaller. Here are the reference of all the properties of a circle.
And this will be the last subtopic, 10.7, Shapes, Plans and Elevations. There are three types of projections, which is plans, front elevation and side elevation. A plan is a scale drawing showing a 3D shape when it is looked at from above. A front elevation is a view from the front. A side elevation is a view from the side.